Hello everyone, welcome back to Physics Talk. Today, Model 3 of the Section 4 in Chapter 1. We're going to talk about acceleration and equations. Acceleration. Make sure you take good notes again as usual. And in this case, do your best to sketch out the graphs. Try to line up the graphs, position versus time, the best you can. So our learning objective is now, instead of using strobe photos and graphs, we're going to use an equation to describe acceleration, which means we're going to be doing some mathematics and computational thinking. And of course, within equations, you got to be able to recognize patterns, be able to see relationships, and then scale, proportion, and quantity, because we are going to do some mathematics. So a reminder from chapter challenge again, you are expected to explain what factors affect following distance, braking distance, and total stopping distance. So anytime you brake or you stop, guess what? You're going to be dealing with acceleration. So acceleration of a car is one of those factors, again, as I said in the earlier video, that affects all of them. And by definition, the acceleration is the change in velocity with respect to time. Change in velocity with respect to time. And in this formula, A, of course, is acceleration. Vf is the final velocity. Vi is the initial velocity. And of course, delta t is the change in time or time elapsed. In time, we're just going to use the t as a symbol down here, because initial time typically we make as 0. Or time equals 0, or we set that to 0. And of course, the triangle, which you see down there, means delta, or change in, okay, change in time. Now, acceleration is a vector quantity. It means how fast the velocity changes. And just as in the lab, you had negative slopes and positive slopes for velocity, acceleration can be negative and positive, which means there's a direction to it. It either has a positive acceleration or negative, and a lot of times we use to the right being positive and to the left being negative, but depending on where you locate your motion detector can determine which way is positive and negative. So in terms of a positive acceleration, here's a velocity versus time graph of the situation where we took a car, we pushed it up toward the ramp, and then let it come back down. Okay, where we pushed it up toward the ramp and let it come back down. So this portion here is where we basically pushed it. This is where we pushed it. And you can see we had an initial negative velocity. And the reason it's negative is because it's heading towards the detector. So it's heading towards the detector. And it has like a negative 0.6 velocity here, going down to negative 0.5, negative 0.25, till it gets to 0 velocity here, which means it's slowing down as it goes up the ramp. And it's only negative because it's heading towards my origin or the motion detector. At some point in time, the velocity then goes from 0, which means it gets the closest point here. And then, of course, it starts going away from it, meaning the velocity starts becoming positive and increases the velocity going down. So in terms of a positive acceleration by definition is just an increase in velocity with respect to time. So the velocity has to be increasing. And so from the lab, you can see from this data, we got 0.25 over here, changing the 0.5 over here, which means the velocity is increasing. Okay, so that's this segment. And this is when it's actually going down the ramp and speeding up. Another situation we can look at is it increases from a negative 0.5 to a negative 0.25. So a negative 0.5 is down here, and it increases to 0.25 here. Now, in terms of speed, this is technically slowing down because a half a meter per second is faster than a quarter meter per second, or 0.25 meters per second. So it is faster. So in this case, it is slowing down for this situation. Okay, but again, it's a positive acceleration because the change is increasing. The velocity is increasing only because it's becoming less negative. But it's slowing down. And why is that actually considered positive acceleration? Because it's whenever you have a negative velocity and you are decreasing in speed, you are technically have a positive acceleration because the change is pointing down to the ramp. And the ramp actually is slowing it down. So that's the reason behind it. We'll explain more of that in detail in class. So the slope, again, is positive, and you can see throughout the whole scenario, whether the velocities are negative down here or the velocities are positive up here, the whole scenario, the slope is positive, and the slope of velocity time graph is acceleration, so that's why it has a positive acceleration. For a negative acceleration, you can see here the opposite direction for this. And of course, for this scenario, we had the motion detector on the bottom, and we actually pushed the car up the ramp till it slowed down, and it came back down again, where you then caught it. So here's that big push as it goes up the ramp, and then of course, the ramp just does its own acceleration system, and then of course, this is where you catch it when it gets to this point right here. So a negative acceleration is a decrease in velocity with respect to time, whereas the positive is an increase. This is a decrease in velocity. So how is this showing a decrease in velocity? Well, you can see over here that I have from the lab 0.5. Velocity decreases from 0.5 to 0.25 during this time interval here. And so that's a decrease in velocity. Likewise, I can go from negative 0.25 to a negative 0.5. Sorry, there's a typo there. There's a double dot. But a negative 0.25 to a negative 0.5. And for that scenario, it's still decreasing, but in this case, it's actually speeding up. Okay, for this scenario, it's actually speeding up because the speed is going from 0.25 meters per second to 0.5. It's just becoming more negative, meaning it's accelerating as it's going towards this guy. And so in those case scenarios, again, as you think about how this is actually working, I am increasing my speed, but I'm increasing it in a negative direction. So it's increasing in a negative direction. So that's why it actually has a negative acceleration. A negative acceleration. Okay, so then we go to the slope again as a reminder, and this is the part you need to make sure you understand, that the slope of velocity time graph again, velocity time graph, is the acceleration from our last video, which means as long as it says a negative, as long as it says a negative slope, this means this whole scenario here, whether it's up here or down here, has a negative acceleration. All right, let's do a little sample problem. So at the start of the race, the toy car increases speed from 0 to 5 meters per second as the clock runs from 0 to 2 seconds. Find the acceleration of the toy car. So we practiced a little bit of this in class, and the equation, of course, the given in this situation is we have the initial speed or initial velocity, we also have the final velocity, and we have the change in time. From 0 to 2 seconds, that's just 2 seconds. Likewise, we can then, since we're actually asked to find the acceleration, what we're trying to find is the acceleration, or A. Our formula for this, of course, looks like this, which we had on the board today. And to do the calculation means that we plug in the numbers. V final is the 5 meters per second. So I'll plug that in right there. The V initial is 0, so I'll subtract that right here. And then the change in time is 2 seconds, so we'll put that guy down there. And then when you plug it all in the calculator, you have to subtract first here, which becomes 5. Then you divide by 2. 5 divided by 2 is 2.5 meters per second squared. And you'll notice the units here is squared, which means that every second, this guy is going to increase 2.5 meters. Every second is going to increase its speed by 2.5 meters per second. It's going to increase its speed by 2.5 meters per second. So at the time equals 0, it would be 0. Time equal 1 would be 2.5. Time equal 2 will be 5. Time equal 3 would then be 7.5. And then time equal 4 would be 10. So it's increasing its speed by 2.5 meters per second every second. That's why it's squared. All right, so Active Physics Plus wants us to determine distance from acceleration equations. So in all of the equations we have so far, there is no distance. So the question is, where do those equations come from? So as you heard me say in the class, this is actually a parabolic shape or quadratic. And so you can actually do what is called a quadratic fit. We're going to do this in class tomorrow. And you can see I have data here. It turns out that this is, of course, a quadratic equation, right? And when I plug in my A, B, and C values, I get an equation that looks like this. Here's the A times T squared. So first of all, since distance is my position here, I'm putting a D there instead. Because it's time on the x-axis, I'm putting T here. Likewise, when I plug in my numbers, negative 1.546 times T, because that's what x is, I'm just replacing variables, plus the constant 1.981. And so this represents the motion for the car on the ramp for one trial that I did. This D value this A value here, this B value here, and C value. The question is, what do these numbers mean? So to look at this further, let's look at the velocity time graph for this exact same motion. So when I look at that for the same time intervals, you'll see I get a straight line, and with a straight line I can find the equation of the line based on the y equals mx plus b. So with y equals mx plus b, I can plug in my slope, I can plug in y in this case is velocity, so I'm going to put velocity here for the y, equals the slope of 7.377 times, instead of x, on the x-axis I have time, plus b, which is negative 1.556. So the question is, what do all these numbers mean? We know that this number here is the slope. The slope of velocity time graph is acceleration. So this number must be my acceleration for my car. Notice it's a positive slope here. Okay? And then the question is, what is this y-intercept? Well, wherever this guy hits, it is going to hit a velocity. So this is actually the initial velocity sitting here. Okay? And so when I bring them together and I look at the comparisons, there are some relationships between these numbers here that we'll explain in class tomorrow. And you can see that this number here is almost exactly the same number. So maybe this number here represents initial velocity. And as it turns out, when we look at some equations, let's look at a sample problem. An automobile accelerates from rest at 5 meters per second every second, which means it has an acceleration of 5.0 meters per second squared. How far does it travel in 3 seconds? So things you got to pick up. The word from rest means initial velocity of 0. So notice on my given, there's initial velocity of 0. The acceleration on my list is 5 meters per second squared. And then, of course, the travel time, t is 3.0 seconds. And it says find the distance. Well, we learned from the first section that the distance formula kind of looks like this, right? And this is the formula you have in your book. I have acceleration I can plug in. I have the initial velocity I can plug in. And I certainly have times that I can plug in. We use this formula when we dropped the ruler or the meter stick to find our reaction time. Now we can use it to actually calculate distance. So the 1/2 times a goes in there. There's my a value. The t, of course, is 3 seconds, and it has to be squared, plus the initial velocity of 0 times a time of 3 seconds. Now, normally I wouldn't write this in. I just put a cross and say this is going to go to 0 because all I care about is this, because this is 0 right here. And then, of course, when you do it in the calculator, make sure you square this first, and then multiply by 5, then multiply by half, or you can do 0.5 times this times 3 squared if you have a squared button on your calculator. And then, of course, when you plug that in, you should get 22.5 meters. Now, we're going to spend more time with this formula tomorrow. We'll give you a better idea on how that works. But for now, that is all we have for today. So if you have any questions, again, come into tutoring. We'll talk to you soon.